Hello, my name is Liew Jun Bin. My metric number is DFOM2007954. So I explained about how aircraft configurations, flat slat setting, and takeoff thrust setting, and airframe contamination, how this kind of factors affect takeoff performance. So first thing first, flaps. That means if the pilots are using higher flap setting or bigger wing surface area will be provided, and that means that the lift force will be generated much more greater, and in that case the takeoff roll will be shortened, and that's because the V speed, the VR and V loft will be much more lower because the lift force is much more greater than usual, and the runway required will be much more shorter. And that's the first thing. Second thing here is takeoff thrust setting. So not every takeoff use toga thrust, or not every takeoff use full thrust. So in that case, some pilots when they take off, they use flex 10 takeoff, or what we call the reduced thrust takeoff, and that means that they are using only 70% or 80% of thrust takeoff, and that's the case whenever the runway is plenty long and they are pretty light, the aircraft is pretty light, and in that case they will use this kind of thrust to take off, and the runway length required will be longer, but because they have quite a long runway, and in that case they will use this reduced takeoff thrust so that the engine could be preserved and much more sustainable. Third thing here is that airframe contamination. Airframe contamination is basically meaning the icing occurs on the wing surface area. So whenever there is ice on the wing surface area, especially on the lower wing surface area, it will cause a great decrease in lift force generated. That's because the lower wing surface area is being designed with a rough surface to create pressure difference, so that the airflow below the wing will be much more slower. So in that case, whenever the ice is kind of smooth, and when the ice is accumulated on the lower wing surface area, and that means that the lower wing will be smooth, and there's no much difference of pressure between upper wing surface area and lower wing surface area, those airflow over them. So the lift force will be decreased, and the takeoff runway length will be long, and the flying performance will be very, very poor. So there's other factors that affect takeoff performance in regards to aircraft configurations. So that's all from me.
My name is Nigel. My metric number is DFOM2007954. So in my part of this group, I'll be talking about how wind will affect takeoff performance. Now, there are a few things to discuss here in this topic, is to understand how the wind speed and the direction affects the takeoff performance. First up, let's talk about headwind actually helps improve takeoff performance. Now, here's a simple drawing for a simple explanation. Let's take a look at this. Headwind is moving towards the aircraft, which is opposite of where the aircraft is heading. Now, we all know that in order for the aircraft to be airborne, lift energy must be sufficient. So therefore, aircraft have thrust for the aircraft to move forward to produce lift energy. How it works is that the wings, underneath the wings, will produce high pressure but low speed. On top of the wings, we will have high speed but low pressure. As faster headwind moves towards the aircraft, it helps produce higher pressure underneath faster, therefore reducing ground speed and also shortening the takeoff distances. But for tailwind, it's the opposite. Tailwind does not help improve takeoff performances like headwind does. Now, let's take this paper as an explanation too. Okay? Headwind comes from the opposite direction, help increase lift energy. But for tailwind comes from behind the aircraft, meaning that it also moves the same direction as the aircraft does, parallel, because it comes from the behind. So because of this reason, tailwind increases ground speed of the aircraft and also increase the takeoff distances. But why have to increase the distance? Is due to aircraft need more time, need more distance in order to nullify the tailwind so that the aircraft can produce enough lift energy to be airborne.
So first factor that affecting the takeoff is the aircraft weight. So the weight limitation, which is MTOW, maximum takeoff weight, are set to ensure the adequate margins of the strength and performance during takeoff. So when loading, the aircraft care must be taken not to exceed the limits given. So the greater the weight, the greater the lift force is required to overcome the weight, therefore greater speed is necessary for takeoff.
There are a lot of factors that will affect takeoff performance of the aircraft. One of the factors is runway condition. Runway with uneven surface will increase takeoff distance, plus that the nose gear take a beating from all those bumps. The soft fill technique helps to prevent against any damage to the nose gear. At some point in time, runway will be contaminated with rain, snow or slush. You will have to allow for these circumstances, as the result can be directional control problem, reduced braking action, or also called as hydroplaning, and more drag on the takeoff. Hence, the runway condition take an important role on the takeoff performance of the aircraft, as many accidents occur during takeoff. That's all from me. Thank you.
Hi everyone, my name is Liew and I hope my metric number is DFOM2004943. So today I'm going to explain how does the air density affect aircraft takeoff. So according to the principle of flight knowledge, density altitude is defined as a pressure altitude corrected for variation from standard temperature. So when conditions are standard, pressure altitude and density altitude are the same. But when non-standard conditions are present, including high altitude, high humidity, and high temperature, air density decrease and density altitude increase. So density altitude is an indicator of aircraft performance and should be calculated before any flights. So why is knowing density altitude is important? Because high density altitude has a discriminated impact on aircraft performance. It reduces lift and impairs propeller efficiency, reducing thrust. As a result, high density altitude can also decrease the engine power output. If it is not accounted for, increased density altitude can cause major problems during takeoff and landings. So as the FAA puts in, hot, high, and humid weather condition can cause a routine takeoff for landing to become an accident in less time than it takes to tell about it. So pilots should exercise caution when pre-flight planning on hot and humid days and adjust for decreased density altitude to avoid accident during takeoff and landings. Likewise, at airport in higher elevation, such as those in mountain area, the high altitude combined with high temperatures can make flying extremely hazardous. Even at airport in lower variations, usually hot and humid days can increase density altitude and make safe operation difficult. So for pilots, high density altitude result in increased takeoff distance, so reduce rate of climbs and increase landing roll distance. So failure to plan for this adjustment can result in an accident. Thank you.